Okay, we have been learning about the difference between rational and irrational numbers today. You've done the house of real, you've listened to the video, you've drawn other diagrams, all with the goal of helping you understand what they are. So, if you remember back to our I can't statements, either on the board or on the TV, the I can't statements were, I can write a rational number as a decimal. Also, we want to be able to take a decimal and write it as a fraction. So those are the two goals today, okay? So the first thing we're going to do is we're going to try and figure out how we can do this. It says every rational number can be expressed as a decimal. Well, that's what we wanted to do. That was our I can statement. So how do we do that? By dividing the numerator by the denominator, okay? So I want you to read that with me. Everyone together. I will read it as well. Try to stay with me. After 2, 1, 2. Every rational number can be expressed as a decimal by dividing the numerator by the denominator. All right, good job. Now, what is the important thing that you need to understand from this sentence? What part of the sentence is actually telling us what to do? Cedric. Very good. So we need to divide the numerator by the denominator. So if we have a rational number in the form of a fraction, to get a decimal, we simply divide numerator by denominator. Now that's easy if we've got calculators, but you're not using calculators today, so we're going old school. Someone tell me what problem number 1 or example number 1 in your book was. What is the problem? Corbin. What fraction are we working with? 5 over 8. Very good. So we've got 5 over 8, and I want to turn that into a decimal. According to our sentence at the top of the page, what do we have to do? Divide the numerator by the denominator. Okay, someone tell me what the numerator is. Madison. 5. The numerator is 5. In this case, it's 5, or the number on top, which means the denominator is what? 8, the number on the bottom. So when we write this out, start with the numerator and just kind of talk to yourself. 5, and then divided by, put the little symbol, and then 8, and now we're going to solve this. And the book does it for you as well. But let's walk through it since it may have been a while since you did long division. So, long division, eyes this way. I'm looking, does 8 go into 5? It does not. So I'm going to put a 0 up here. I've got to remember my decimal point, put it there and on top. All right, I'm going to add a 0. Does 8 go into 50? It does. How many times? 6, are we sure? What's 6 times 8? 48. And then I subtract. What's 50 minus 48? That's 2. Very good. And then what do? Add a 0. Now, why am I able to add a 0? Is 5 any different than 5.0? Does adding zeros after a decimal point change the value of a number? So 5.0 is the same as 5.00. It's the same as 5.000. So that we're not changing the number. All right? We're bringing that down. Does 8 go into 20? How many times? Twice. 2 times 8 is? Okay, 16. Subtract and we get 4. Bring down yet another 0. I try to put these arrows in. It usually helps you keep lined up and straight and organized. Does 8 go into 40? How many times? 5. Exactly 5? Very good. So 5 times 8 is 40. We have 0 remainder. So 5/8 written as a decimal is 0.625. All right? How are we doing? Think we got it? Okay. I want you to try another example real quick. Somewhere on the side of your page, I want you to try this one here. All right? 3 over 16. So in the margin, somewhere blank space in your book, try this one real quick. I'll leave the other one up there so that you can see it if that's helpful. How many people are wishing they had a calculator right now? All right, you've had a chance to look that over yourself. You're probably not done, but let's start working on it together. So, I'm going to write 3 divided by 16. 16 does not go into 3, correct? So I'm going to put a 0 here. Decimal points. Does 16 go into 30? 1 time. 1 times 16. If I subtract those, I get 14. I'm going to bring down a 0. 16 goes into 140 how many times? Anybody got that far? Well, I know 16 times 10 is 160. That's too much, right? That means 16 times 9 would be what? 144. That's too much. So it must be 8, right? So 16 times 8 would be what? 1. Anybody? Someone figure it out. 128. So 16 times 8 is 128. If I subtract those, I get what? 12? Bring down another 0. And so 16 times 8 is 128. Now I need it to go into 120. So 8's not going to work. Probably going to go down to 7, right? Very good. So 7 times 16 is going to be what? 112. Very good. Okay. And then if we subtract those, 8, bring down one more 0, and 16 goes into 80. Well, remember, 16 is just 2 8s, right? 8 goes into 80 how many times? 10 times, right? So 16 would go 5 times. Okay. So 3/16 as a decimal is 0.1875. Now, I gave you 2 problems that were not very easy. They were fairly long decimals. If I gave you a number like this, 3/6, it would be pretty easy, right? I would do 3 divided by 6. 6 does not go into 3. It does go into 30 5 times, and you're done, 0.5. Okay? So just keep that in mind. Morgan, question. If you simplified it, that would also be easier. All right, so those are our first basic ones. All right, now someone take a look at example 2 and tell me what is the difference between example 2 and example 1. Actually, tell your partner, what's the difference between example 1 and example 2? All right, who can tell me? Savannah, what's the difference? Okay, we got a whole number out front, all right? So we call this a what? When we have a whole number and a fraction, we call it a mixed number. Very good. Now, this mixed number complicates things slightly, but I think we can handle it. There's 2 options. Number 1, you can change the mixed number into an improper fraction. Can anyone remember how to do that? So remember, like you put like a little multiplication there and plus here, right? And 3 times -1 is -3 plus 2. Very complicated. All right. So I think, well, what should that be? Should be -1 is what it should be, right? So you must have to leave the negative off to do that. So I don't think I've done that before. So it should be like -5/3, right? Okay. So you can change it to an improper fraction and then solve it. If you want to do it that way, that's great. Here's what I recommend. I recommend kind of splitting it up. Okay? Right? Our decimal is probably going to have whole numbers with it too, right? So we can figure out what the fraction is and then come back and add that whole number on, okay, or that integer on, right? So I just need to concentrate on 2/3. So 2 divided by 3. 3 does not go into 2. 3 goes into 20. 6 times, right? 6 times 3 is 18. 2, bring down the 0. 3 goes into there, what? 6 times. Do we see a pattern? All right. It's repeating. So if we want to write this out, it would be, don't forget, we're going to take the whole number the integer that was out front, and we're going to get negative 1.6, and then we can just go with repeating. All right? So the only difference between the first example and the second example is a little work to do, such as splitting the whole number from the fraction or turning it into an improper fraction, whichever way you prefer. What I'd like you to do right now is I would like you to try the got it problems at the bottom of the page. Got it problems, I'll give you, there's 4 of them, so I don't know, 4 minutes? Go for it. We'll set it up. Start off by setting it up. Set the problem up. Okay? So what's the first one? What's got it, A? 3 over 4? Or is it 4 over 3? No, it's 3 over 4. Okay, so how do I set that up? 3 divided by 4. All right? Now keep working on it from there. All right. Let's finish A first of all. Does 4 go into 3? No, it does not. Does 4 go into 30? How many times? 7. 7 times 4 is 28. 30 minus 28. 2, bring down a 0. 4 goes into 20. 5 times exactly. So 3/4 as a decimal equals 0.75. Okay. What's one of the other ones you would like to see?
I want to see number C. Letter C.
I'm hearing C. So let's separate. Let's separate 4 and 13 over 25. Right? Remember I said separate it. We'll add the 4 on later. So now it's going to look like 13 divided by 25. 25 cannot go into 13. It can go into 130. How many times? 5?
Yes.
5 times 25 is 125. If we do our subtraction, we get 5. Bring down a 0. I got 50. 25 goes into 50. 2 times. Exactly. So I've got 0.52. But remember, that is just the 13.25. So 13.25 equals 0.52. We need to add on the 4 from the beginning. So our answer should be 4.52. Okay? What part do you not understand? Yes, that's a great question. So for problem B, we had negative 2 over 9. If you just solve 2 over 9 first and then add the negative on the front, then you'll be fine. Okay? So 2 divided by 9, I believe it ends up being 0.2222. Am I correct? Because I think you keep getting 20. All right. And we have to remember that's negative, so our answer would be negative 0.2, and it's repeating. That would have been B. And then for C, your answer should have been 3.09 with a 0.9 repeating. No, for C. No, what did I say? For D. For D. Letter D. Okay? 3.09 with a repeating bar over the 0 and the 9. All right. So this is the basics. Take the numerator, divide by the denominator. Okay? Now, obviously, when you're at home tonight, you may use a calculator instead. Okay? Which will speed this process up. But it's good to go back and practice the old school habits. Okay? Of course. All right. I'm going to skip example 3, and I want to look at example 4. Now, example 4 is different because in example 4, now we have a decimal already, and we want to turn that into a fraction. Now, this, I think, is actually pretty straightforward, okay? So if you notice, it says when writing a decimal as a fraction, the place value of the last digit will be the denominator. All right, I need everybody to read this with me. If I don't see your eyes up here and your mouth moving and hear your voice, then I write your name on the window. All right, everybody read with me after 2. 1, 2. When writing a decimal as a fraction, the place value of the last digit will be the denominator. All right, the place value of the last digit will be the denominator. Okay, so our example is 0.45. That is our decimal. And I want to write that as a fraction. Well, what is the place value of the last digit? First of all, what's the last digit? The last digit is 5. And 5 is in what place? Hundredths, right? It's in the hundredth place. So the place value of the last digit is my denominator. So it's in the hundredth place. So my denominator is going to be 100. And then what do I put in the numerator? 45. Okay? Now, because if you read this, 0.45, if you read it like you're supposed to, it is 45 hundredths. Okay? So if you know how to read decimals properly, then it's easy to put them into fractions. Now, can we leave a fraction like this? What do we have to do? Simplify. So what can I divide both the numerator and the denominator by in this case? What do you think, Connor? What can I divide both the numerator and the denominator by? Well, does it look like 5 would be the easy one to go into both of them? Okay, what's 45 divided by 5? That would be 9, right? And what's 100 divided by 5? Very good. All right, and I don't think they have any more common factors. So 0.45 as a fraction is 9 over 20. Okay? Let's do one more example. .32. So this is similar in that What is the place value of the last digit? Still hundredths. So how am I going to rewrite this? Very good. 100 on the bottom, 32, and then I can simplify from there. Okay? What goes into 32 and also goes into 100? 2, what else? Not 12. Does 4 go into 32? How many times? 32 divided by 4 is 8, and 100 divided by 4 is 25. Okay? So 0.32 can also be written as 8 over 25 or 8/25. Okay? All right. What's really good to understand also, before we move on, I guess it's good to know the place values, right? So do you guys know what these place values are? So going this way, I start with what? Ones, right? Ones, and then tens. Are you sure? Okay. All right, thousands, 10,000s. Okay, now this way, this is when you have to start spitting to say it properly, right? Because you got to add the THs on the end. But do we start with once? No, there's no once. Okay, so the first one down here then is tenths, all right, and hundredths, and so on and so forth, okay? So keep that in mind. Now, here's the most tricky one, but if you bear with me, I'll show you how to do it and show you the trick. Okay, I'll show you the trick. What if they give you a repeating decimal? All right, so they say, if you take a look at example 5, for example. What if they say, I want you to write 0.5 repeating as a fraction? Well, what do you do with that? Okay, well, we know that 0.5 is the same as 0.555, etc. Okay, and I'm going to let the letter n equal 0.555. All right? So we've kind of got ourselves a little equation here. Is everybody okay with this? All right, now, if I multiply both sides by 10, all right, that means over here I've got 10n. And what happens to the decimal point when I multiply by 10? Moves. So over here I have what? 5.55. Okay, and so on and so forth. Okay? Now, if I go ahead and subtract n from both sides, if I subtract an n from here, 10n minus 1n would leave me with what? 9n's. And I also know that n equals 0.555, or everything after the decimal point. So if I subtract 555, I'm left with just 5. Okay? Now I want to get n by itself. What do I do? Divide by 9, divide by 9, and now I've got 5/9. So, very long, complicated way of saying that 0.5 repeating is the same as 5/9. Now, I noticed a pattern. Check this out. This is cool. That's not what I wanted to do. Try this. 0.5 equals what? 5. What place is this in? Tenths, right? So it's 5/10. 0.5 repeating was 5/9. Interesting. If I were to do 0.7, that would be what? 7 in the tenths place. If I were to do 0.7 repeating, guess what I would end up with? 7/9. Interesting. So anytime you have something repeating, the denominator, instead of becoming that 10, becomes a 9. All right? Now, also, there's another tricky one. What if I have 0.55? Well, that's the same as 55 hundredths, correct? What do we think 0.55 is going to be repeating? 55 over 99, exactly. Okay, so there is the proof for how to do it. It's also in your book. The shortcut is to know that that denominator is either going to be 9 instead of 10, or 99 instead of 100, or 999 instead of 1,000. Okay, so go ahead and try the got it's on, they're actually on page 10. Try the got it's on page 10. Are they on page 10? Okay. Got it's F and G above the guided practice.